State diagrams is sort of the ugly child that the cat dragged in the UML context, but nevertheless it can be a useful tool to figure out states and state transitions in a program. So let's get started in the notation of them. I'll be using plant UML for this one as well. Star UML has support for state charts, but there are certain things that I want to be able to do that it thinks I shouldn't be allowed to do. So I'm going to go with the text-based version as usual. As usual, start with, so in plant UML at least, start with a textual description of what I want to do. So what do we have in a state chart? We have, let me just clean up things a bit. Just so that I get the diagram drawn in the right direction and with a nice title on top of it. We have a state. Let's see how that one looks. Simple. A bubble with a name. Nothing more than that. If we have, we can have a starting state. Like a black ball like that. This means that this state diagram begins here and immediately transitions into a state. From a state to another state, let's do something like that. This is a simple transition, like that. I can put events. Evaluate this and see. Now what I've done is that I'm stuck in this one until this event occurs, and then I'm moving on to this other state. So I can, if I make one more, so I'm stuck in a state until an event occurs, and then I'm moving over to another state. Or if some other event occurs, I'm getting to a third state. I can put guard conditions on here. Like that, or any type of Boolean expression here. So what happens now is that if event occurs, well, if the time, whatever time means in this case, has elapsed more than 2 minutes, then I'm transitioning to another state. If time is less than 2 minutes, well, even though event occurs, I'm still staying in a state. I can also do actions on the transitions. Like this. So, if I'm in a state, an event occurs, time is more than 2 minutes past, whatever that is, whatever starting time I had. I will follow this transition, and while following this transition, I will call the method eat ice cream in order to get to another state. This is something that we're going to discuss in the class as well, because it's very easy to confuse the event with the event action. So what else can I do? I can put entry events and exit events and stuff on a particular state. So let's do that on the first one. This means that whenever I enter a state, I call mom. So the reason why I would want to do it here rather than on the transition is that I may have more than one arc going into this state. So if I do like this, just to explain this a bit. You see, I've now got two arrows coming into a state from the starting condition and from another state. So rather than putting call mom on both of these transitions, I'm doing it when I enter a state. I'm doing the call mom method. In the same way, I can do an exit condition or exit action, sorry. So whenever I'm leaving this state for whatever reason, if I'm going, if event occurs and I'm going along this arc, or if some other event occurs, I'll be doing call dad. I can also have actions happening while I'm in the state, and that's the do. So while I'm in the state, I'll be calling this method. What else can I say about this? Yeah, there's one I can do. I can transform or transition to myself. Why should I do that? Let's perhaps. So I am in a state, I drop my ice cream, but I'm still in a state. Only more so possibly since I don't have any ice cream anymore. This means, by the way, that so when dropped ice cream occurs, I'll be calling dad, since that's the exit criteria or exit action, and I'm re-entering the state, so I'll be calling mom. And then I'll continue to do something. Okay? The final thing that I would like to show in terms of notation is the end state. Which is, again, a black ball, but with a circle around it. So, this one is a starting one. Look for that one if you want to figure out where do I start this state chart or state diagram. I will immediately come into a state. If I have an event, I'll come into another state. And since there's no condition here, I'm immediately going back again to a state. If some other event occurs, I'm stuck in a third state. Actually, I can't get away from this one. And I should probably have, since I have events on all other actions going out of a state, all other arches going out of a state, I should probably have one here as well. But sometime, eventually, I'm going into this end state. What did I do now? Thank you. So let's do a more elaborate example of this. Let's hide this a bit. With the let's model one of the ghosts in Pac-Man. So I'm starting, and I go into a hunting mode. And this happens when the game starts. And from hunting, or in the hunting state, when I enter it, I'll change color as a ghost to be blue. While I'm in the state, my job is to find Pac-Man, right? And according to some strategy, each ghost has their own strategy in Pac-Man, but I'm going to move on the board according to my strategy, either closer to Pac-Man or away from Pac-Man. And that's basically what I'm doing in the hunting state for the moment. And then, if I find Pac-Man, I'll be moving over to an eating state. If I find Pac-Man and start eating, I'll play some sound. And this is from the perspective of Pac-Man, that Pac-Man just lost a life. And once I'm done eating, I'm going back to hunting again. While I'm in eating, I'm a happy ghost, so I'll be cycling all my colors. When Pac-Man eats a candy, I'm changing my strategy from hunting to running. Candy. This probably is a bad idea that it's the ghost that plays these sounds, but I'm putting them here just to illustrate. Since I have more than one ghost, what's going to happen is that when Pac-Man is found, well, that's one is easy because there's one ghost that finds Pac-Man at one particular time, so that's one is okay, even though this would be better modeled by Pac-Man itself. But here, when Pac-Man eats candy, you have three ghosts all playing the power-up sound. So that's probably a bad idea. But I'm keeping it anyway, just for the illustration purpose. When I'm in the running state, I'll change my color to red. I'm still trying to find where Pac-Man is. And trying to get away from him this time. And from running back to hunting. When the power-up has timed out. Let's cycle the colors there too, saying, hey, I'm back in the game again. So while I'm in the running state, I can be eaten by Pac-Man when Pac-Man finds me. And if that happens, I'm going into the eaten state, and while so doing, I'm playing the score up sound. Again, this is probably something that Pac-Man should do instead of the ghost, but you get the general idea. From eating, I can end the game. Remember, eating, that's when I found Pac-Man and I'm eating him. And I may then actually have game over. And if there are no more lives, I'm going into the game over state. Or actually, this is better expressed like this. And then just tidy up this a bit. Or actually, let's see what we've got so far. So, the game starts. I'm in my hunting state. When I find Pac-Man, I'm going into the eating state and cycle my colors. Once I'm done eating, I don't have to put anything on this transition. Once I'm done eating, I'm going back to the hunting state. If Pac-Man eats a candy, I'll go into my running state. If Pac-Man finds me, I'm being eaten. Otherwise, there's a timeout, and I'm going back to the hunting state again. So hunting, find Pac-Man, eat him up, and he's got no more lives, so game over. That's what we've got so far. There are a few things to clean up this a bit further. So from the eaten state, there's a respawn state. And when I respawn, I always respawn in this pen in the middle. Do. And they cycle the colors for a while. And after a couple of seconds, or something like that, I go from respawning to back to hunting again. So that's just to clean up. So we've got more or less the full. Hang on, hello. More or less everything that Pac-Man or a ghost in Pac-Man does. So this is a good example, or a fairly decent example at least, of a state chart. And why I'm saying that this is the ugly child in UML is because it's not really connected to anything else. This is more of an analysis tool. Yes, you can use methods and method calls like this, but it's not mapped to any particular class. It's not mapped to any object or any. It might be a combination of many use cases here, or just one, or just a subset of a use case. So it's difficult to fit it in, but it's still a useful analysis tool. So that's state charts or state diagrams for you.